Hey there, this is Guided Practice 2. So we are on part 2 of section 1.3. We're working with factoring. Now, our strategy when we're just kind of mixing things up is I'm always first going to look for a greatest common factor. And then I'm going to see if I have any trinomials or anything special, okay? So number one, I've got a lot of variables going on here. This is likely going to be just a greatest common factor because so much is going on. So let's take a look at each piece. So the numbers, I've got an 8, a 16, and a 12. Those all have a factor of 4 in them. So I'm going to bring a 4 outside. Then I'm going to look at the x term, and there's an x to the 5th, an x cubed, and an x to the 4th. Each term has at least 3 x's. So I'm going to take an x cubed out front. And then when we look at the y's, we've got 3, 1, and 2. Each term has at least 1, so I'm going to pull 1 out front. Then we go term by term and see what's left. Okay, so the first term for my 8x to the 5th, y cubed. So for the 8, I took out 4, so 8 divided by 4 is 2. For x to the 5th, I had 5 x's. I moved 3 out front, so there are 2 left. For the y cubed, there are 3 y's. I have 1 out front, so I still need 2 more. All right, next. By the way, when you're thinking about that, remember I said you divide through by what you factored out. And so when you think about your powers, dividing means subtracting. So 5 for the x minus 3 out front gives us 2 left. All right, next for the 16. So it's minus. 16 divided by 4 would be 4. X cubed, I have 3 x's. We pulled 3 out, so there are none left. And there I have 1 y, and we pulled a y out, and so there are none left. So it's just minus 4. In our last term, take that 12 divided by 4 and gets us 3. I have 4 x's in the last term. I pulled 3 out, so I have 1 left. And I have 2 y's. There's 1 out front, so I need 1 back here. And so that is my final answer. Number 2 is a trinomial in which we have our leading coefficient out here is just 1 because it's not written. And so all we need to do is take a look at this last term. So we want two things that multiply to 12. And they need to add to negative 7. So multiples, 12 has factors. Let's talk about its factors. So we can go 1 and 12, 2 and 6, or 3 and 4. And I need to make 7. If I add or subtract, the only one that are going to give me a 7 is going to be this one. So I need 3's and 4's, but should they be positive or negative? Well, they need to multiply to positive 12. So they both have to have the same sign, but I need them to add to negative 7. So I need to have them both be negative. So negative 3 and negative 4 will multiply to positive 12 and add to negative 7. And so that means my factored form is going to be x minus 3, x minus 4. And we can check it and distribute and FOIL it out, and we will get exactly back where we started. For number 3, this is a trinomial, meaning it has 3 terms, but that leading coefficient now is no longer 1. I've got a 4 sitting out front. So I'm going to go 2 different things here. So first of all, you don't have to do this, but I noticed right away that 4, 10, and 6 are all even numbers. So I'm going to go ahead and factor a 2 out of those. Bring the 2 out front. Ooh, sorry about that. When you take out that 2, what's left? Well, if you take it out of 4x squared, that's 2x squared. Take 2 out of 10x, that's 5x. And 2 out of negative 6 is negative 3. But I've still, now in parentheses, have a trinomial with a coefficient that's not 1. So I'm still going to go box and circle here. So here's my box. That first term, oh, sorry, and I copied it wrong. There should be a square right there. The 2x squared goes up in the upper left, and the negative 3 goes bottom right. Then I'm going to, in my circle, goes those 2 numbers multiplied together, so negative 6. That means that I need 2 numbers that multiply to negative 6 that add to negative 5, that middle term. So let's see. I've got 1 and 6 and 2 and 3. So, but I need this to be negative 6, so I need one of them to be negative. So I need either negative 1 and positive 6 or positive 1 and negative 6, negative 2, positive 3, or positive 2, negative 3. Those are my 4 choices. If I add them all together, I need negative 5. So let's see. Negative 1 and 6 is going to be positive 5, so that's a no-go. Negative 2 and 3 is positive 1, that's a no-go. 2 and negative 3 is negative 1, so nope. But 2 and negative 6 will give me negative 5, which is what I'm looking for. So I put each of those in a box. So 1x, I'm not going to write the 1 in front of the x, and negative 6x. Again, if you switch them, that's fine too. And then we're going to factor the box. So the top row, the 2x squared and the negative 6x, we're going to factor out what it has in common. They both have an x, and 2 and 6 both have a 2. So we're going to pull out a 2x out front. What's left when we do that? So take 2x out of 2x squared, you have an x left. Take 2x out of negative 6x, and you have a negative 3 left. In the bottom row, to get the x in the bottom left, I need a 1 to the left. 1 times x will give me x. And a negative 3 up top gives me a negative 3 times 1 is negative 3. So that means my factors, which I'm going to take over this way. So I had from above 2 on the outside. Then my two factors are x minus 3 across the top and 2x plus 1 along the side. And that is my fully factored version. All right, number 4. We've got 4 terms here. And they do actually all have a 3 in common. So let's go ahead and take that 3 all the way out to start us off. So if we take out a 3, that's going to leave me with x cubed, x squared, minus 9x, minus 9. Okay. Now, I still have 4 terms here in the middle, and I'm going to group 2 at a time. So I'm going to take these 2, and then I'm going to take these 2. So for the yellow ones, and I'm going to leave this 3 out front, and I'm going to make it a big bracket so that I have some room to work with. So x cubed plus x squared, they both have a common x squared. So let's take that in the front. And what's left is x plus 1 to give me what's in yellow. Then in the second 2, where it's blue, they both have a negative 9 in common. So negative 9. When I take that out, I get x plus 1 as well. And now you can see that that worked because now I have an x plus 1 in both places. So what that means is we're going to keep the 3. Then we're going to pull out the x plus 1 to the front. And what I have left is the x squared and the minus 9. So x squared minus 9. Now, I'm almost done, except the x squared minus 9 is special. This is a difference of 2 squares, right? The square root of x squared is x, square root of 9 is 3. So that means that my final factored version, I'm going to keep the 3 and the x plus 1, and the x squared plus 9 will be x minus 3 and x plus 3. So that one had quite a few of our factoring strategies in it. And just so that it looks a little bit better, I'm going to move this to the side so that we can kind of all see it together. All right, and number 5, not quite our last one, but close, x squared minus 36. This is a difference of 2 squares. So the square root of x squared is x, square root of 36 is 6. So this is going to factor as x minus 6 and x plus 6. Doesn't matter whether you go with the minus first or the plus first, your choice. And then our last one, these are 2 perfect cubes. This is a difference of perfect cubes. The cube root of 8 is 2. Cube root of x cubed is x. So the cube root of 8x cubed would be 2x. Cube root of 1 is just 1. And so if we remember, our formula is a minus b times a squared plus ab plus b squared. So if I fit that to the formula where my a is 2x and b is 1, I'm going to have 2x minus 1 times 2x squared would be 4x squared. I already have a minus, so we switch the sign to plus. A times b, that's the 2x times 1 is just 2x. And plus b squared is just 1. Okay, and that'll take us to the practice problems.